Hello, hello, and welcome back. In this video, we are working through an example where we will be finding the equation of a plane given 3 points. So this is different than the last video where we were given the normal vector and a point on the plane, and then it's very easy then to come up with the equation of the plane, right? We have a formula, or we can just go back to the dot product. So this is a little bit more complicated. There's an extra step involved here. Again, what we need, if we can get a hold of, so I'm going to write here, need point on the plane. Well, that's easy. We got 3 of them. So check on that one. We can pick any of these 3 points. But we also need a normal vector. So a vector that's normal to the plane. And, well, we don't have that. So this is really what we need to get a hold of. So we need to find a vector normal to this plane. Well, how can we do that? Turns out, last week when we were looking at cross products, we actually did a problem very similar to this one. The idea was we wanted to find, I believe, a vector normal to the plane containing these 3 points. And that's exactly what we need to do here. So you might refresh your memory on how we did that. Remember that the cross product, if I give 2 vectors that are not parallel to each other and I compute their cross product, the output, that vector that comes out of it, will be orthogonal to both the vectors. So that is u cross v is orthogonal to both u and v. So those are the facts that I'm going to use to come up with this. I'm going to give you a real quick demonstration with one of our interactive figures in the e-text. So here there's just 3 points. It's not the 3 points we're working with necessarily, but 1 point, 2 point, 3 points. There's my 3 points. The idea, and if you remember back to that previous example, we picked 2 vectors out of those 3 points. So maybe these 2. So this looks like PQ and PR. Something like that maybe. And then we compute the cross product of those 2. The output will be a vector that's orthogonal to them. And what's cool is if I pick my vectors right, so if I do say PQ and PR, then those 2 vectors are both, they're non-parallel to each other and they're both in the plane. And so if I find something normal to that, that'll be normal to any point in the plane. That's the idea. So let's work through finding that. All right, so back to here. So I'm going to pick PQ and, I don't know, I'll do PR, but it really doesn't. I'll do PQ and QR. Why not? It doesn't matter. Just pick 2 sets of 2 of these points and compute the vectors. So I'm going to pick, again, doesn't really matter. Pick your favorite 2. I'm going to pick PQ and I keep changing my mind. I'll do PR. Why not? So PQ would be the vector. So what? It goes down 1, up 5, and down 3. And then PR looks like I need to go down 2 in the x direction. I stay the same in the y direction, and then I go up 2 in the z direction. So -2, 0, 2. I'm going to compute their cross product, and that's going to give me a normal vector to the plane. So I'll do PQ cross PR. And that, remember, is the determinant of a 3 by 3, the determinant of I, J, K, 1, 5, -3. And remember the direction for this normal vector, so long as I'm doing the plane here, the direction, if I do PQ cross PR or PR cross PQ or some different combination of these, it's not going to matter. I'll get different vectors out here, but then when I do the rest of this to find the equation of the plane, I'll end up with the same thing. So let's see, -2, 0, 2 would be the rest of this, and I'll work that out. So this is, again, hopefully you're comfortable enough with computing these determinants by now. If not, come see me in office hours. That'd be great. So the I component, that's going to be 10 minus 0, so this is 10I. And you know what? I'm just going to write it in component form. It's going to be 10. The J, remember, gets negatived. So it's 1 times 2, 2, minus positive 6, so that's a negative 4, but j gets swooped around, so this is 4. And then for k, 0 minus negative 10, that's a positive 10. So 10, 4, 10 then is orthogonal to both PQ and PR, and hence it will be normal to the plane. So cool. I now have my normal vector, so that's n. And now I have a point in the plane and I have a normal vector n, and so now I can go through the rest of the steps to find the equation of the plane. So maybe I'll draw a little squiggle here. I'm just going to go and go ahead and use the equation. So this is my A, B, and C, right? A, B, and C if you're looking at the formula. This is A, B, C. And then I'm going to pick P to be my point on the plane. It doesn't matter which one you pick. We'll get a similar equation regardless. So 2, negative 1, 3. So this is going to look like AX plus BY plus CZ. So that's 10x plus 4y plus 10z equal to the dot product of n and this one. So that's 2 times 10, that's 20, minus 4. Let me do this calculation down here. 20 minus 4 plus 30. So that's 50 minus 4, that's 46. That's the equation of the plane. Pretty neat, right? So again, another multi-step problem. We approached it by determining what we needed to come up with the equation, and then we broke it down. We found a cross product as a smaller step, and then used that normal vector to find the equation of the plane. All right, guys, that's it for this video. I will see you next time. We'll talk about angles between planes.